When working with gases, we can actually create additional conversion factors. Some important information for you to know is that at standard temperature and pressure, which is called STP, that occurs at 0 degrees Celsius and 1 atmospheric pressure, so ATM. 1 mole of any gas occupies a volume of 22.4 liters. What I want you guys to think about, at standard temperature and pressure, that's not going to reflect what we're working with in lab most of the time. So most of the time we're working, very closely to that 1 ATM in ESCO, Minnesota, but our temperature, thankfully, isn't going to be 0 degrees Celsius when we're working in lab. Our temperature is usually right around a 23, somewhere between 23 and 25 degrees Celsius in our classroom. So the conditions that we're talking about here are ideal. And later on, towards the end of the course, when we're studying gas laws, this concept of molar volume and STP will come into play in just about every situation that we deal with. All right, so it's really cool. So we have these 22.4 liters per mole, or 1 mole will occupy a volume of 22.4 liters. That's called the molar volume. So it's just another way that we can actually convert if we're dealing with gases. Simple things here. If I have 19.2 liters of gas, how many moles of gas am I working with, assuming that I'm at that standard temperature and pressure? If I am not at standard temperature and pressure, then there are other equations you use, but we're not going to be doing that in this unit. So that would be focused in on the gas laws unit. Just like anything, I'm just setting that starting value up over 1, and then I'm going to use the conversion factor that 22.4 liters of hydrogen gas, there will be 1 mole. And then if I do some really quick math on that, 19.2 divided by 22.4, I get 0.857 moles of gas. Now, really the sky's the limit here, because you know that if you have moles of anything, you could figure out how many compounds there are. You could figure out how many atoms there are. You could even figure out the mass of that sample. So really, this is one additional tool that will unlock a whole other series of problems that you could solve. For example, they could give you the mass of the gas. You could then take mass of that gas, convert to moles, and then you could convert to volume. So you could figure out how much does a certain mass of, what volume does a certain mass of gas occupy. And you're always going to go through moles. Like, that's the biggest thing from this unit. If you can find a way to get from the unit you're starting at, get to moles, you can go to compounds, moles you can go to grams, and now with moles, you can go to volume as long as you're dealing with a gas. All right, one more quick little example here. So 3.94 moles of CO2 over 1, and then we can say that 1 mole of CO2 occupies a volume of 22.4 liters. Again, this equation only works at standard temperature and pressure. So 3.94 times 22.4 gives me 88.256, so 88.3 liters of CO2. Why would that be important to know? Well, if you were actually generating gas, so you were doing a chemical reaction, and you were trying to make a prediction for how much gas would be produced, this would be incredibly important information to know. If you don't need very much gas, like when at the end of the year we make water bombs, we generate hydrogen gas and oxygen gas, and we mix them in a 2-to-1 ratio to make a really cool, loud reaction. We need to be able to determine how many milliliters of gas we are dealing with, because we're dealing with very, very small quantities. And then we need to be able to work backwards and figure out, well, how much chemical should I use to be able to create that reaction? So this is really useful information to know kind of going forward.